5 NBA accredited programs, advanced computing facilities, internships and placements right on campus. Designs made for the future. Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts. Where learning doesn't end in the classrooms. Explore arts, sports, and endless opportunities. Study at an institution with legacy. Christ College of Engineering. Admission inquiries open. Christ College of Engineering. 5 NBA accredited programs, advanced computing facilities, internships and placements right on campus.
Thank you, Abhinav. Been a long time. Hello, Abhinav.
Designs made for the future.
Yes, teacher.
So let's move on.
Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts. Where learning doesn't end in the classrooms. Explore arts, sports, and endless opportunities. Study at an institution with legacy. Christ College of Engineering. Admission inquiries open. Christ College of Engineering. 5 NBA accredited programs, advanced computing facilities, internships and placements right on campus. Designs made for the future. Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts. Where learning doesn't end in the classrooms. Explore arts, sports, and endless opportunities. Study at an institution with legacy. Christ College of Engineering. Admission inquiries open. Christ College of Engineering. 5 NBA accredited programs, advanced computing facilities, internships and placements right on campus. Designs made for the future. Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts. Where learning doesn't end in the classrooms. Explore arts, sports, and endless opportunities.
No, ma'am. I'll be
Study
turning
at
that
an
off
institution
when
with legacy.
the
Christ College of
our guest
Engineering.
join.
Admission inquiries
That's all.
open.
So right now they can join and they can also turn on.
Christ College of Engineering. 5 NBA accredited programs, advanced computing facilities, internships and placements right on campus. Designs made for the future. Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts. Where learning doesn't end in the classrooms. Explore arts, sports, and endless opportunities. Study at an institution with legacy. Christ College of Engineering. Admission inquiries open. Christ College of Engineering. 5 NBA accredited programs, advanced computing facilities, internships and placements
Working
right
so
on
that
campus.
it is functional, no? So that is why I was just checking. Right. Nice of you to join you. It's working very well and we can see you very well. Okay. Thank you.
Designs made for
We
the
will join
future.
you. Thank you.
Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts. Where learning doesn't end in the classrooms.
Nidhu and Suni, can you have some more light
Explore
on your
arts,
face?
sports,
Some more light on
and
your face?
endless opportunities. Study at an institution with legacy.
You're in the
Christ
sort of a
College
shadow.
of Engineering. Admission
Is this fine?
inquiries open. Christ
just
College
kept
of
it up.
Engineering.
Mistree, I think that's also possible.
5
Isn't
NBA
it? I think
accredited
there's
programs.
a provision for brightening
Advanced
of your
computing
screen.
facilities.
Could be
Internships
that
and
I have not
placements
brightened
right
up
on
my screen.
campus.
Oh yeah, now it's better. Okay, I have brightened up my screen.
Is this better now?
It's much
Designs
better. It's
made
much
for the
better.
future.
Still, there are some shadows. Okay, please, anyone can help them.
Advanced lab facilities for hands-on training. Mentorship from industry professionals and experts.
The video is fine, right? I mean,
It's a lot better. It's a lot better from where we started off. Welcome, Professor Pritpal Singh. Very nice of you to join early. So it must be early morning right now, isn't it? Is it early morning out there? I can't hear you. I think you're muted, Professor.
Yeah, it's about 11:15 here, so not too early.
Okay, not too early. Okay, yeah. So we didn't trouble
Yeah.
you too much, but it's very nice of you to join us because we are very expectant about the IEEE Humanitarian Technologies Board.
Yes,
We are
happy to
having
join.
quite a lot of problems launching this kind of conference, and we'll need your advices. We'll need your help, and in many ways. So I'm very happy that you have joined us today,
Yes, very happy to be here.
and
Thank
very
you.
early too. That's good.
Yeah, so I guess you'll let me know when I need to start. And
Yeah, there will be a queue. In fact, there'll also be a photograph coming over, and then we'll definitely let you know. Okay, so there's a short bio of yours will be read by one of the students that precedes your talk.
oh,
You
okay.
want us to, yeah, if you want us to show the video, to show your slides, we'll do that. Otherwise, you can do it on your own. Would you like to check out now? Would you like to present
Yeah.
and see?
Let me see.
Just a minute. I think we'll have to retract our slides. Nitin, perhaps we'll have to stop our slideshow such that he can take over for a minute. Yeah.
Okay.
Can you put it on what do you call it? That kind of mode, where in slideshow mode.
Yeah.
Hello, sir. Sir, ചേരുന്നില്ലേ? ആ. ഒരു ലിങ്ക് ഇട്ടുണ്ട്. ആ ലിങ്കിൽ ഇത് ചെയ്താൽ മതി, ഒന്ന് ക്ലിക്ക് ചെയ്താൽ മതി, അല്ലെങ്കിൽ അത് കോപ്പി ചെയ്ത് ബ്രൗസറിൽ പേസ്റ്റ് ചെയ്താൽ മതി, എങ്ങനെയും ജോയിൻ ചെയ്യാം.
Okay, can you see my first slide?
Yes, sir.
Okay,
it's not in slideshow mode. We are not able to see it in the slideshow mode.
Yeah.
How about now?
No, sir. When you were giving present,
You can do it again.
screen,
You have to share your entire screen. That is, while you are presenting, start presenting, I think you have to share your entire screen. Then the slide drop will be visible.
Let me try again. Wait.
എങ്കിലും എല്ലാവരുടെയും
Sound is clear?
വീഡിയോ ഓഫ് ചെയ്തോട്ടോ അവരൊഴികെ.
Okay, so you can see it now, but it's not in full screen mode, right?
Yeah, it's not in full screen. I think you
Okay.
can start.
How about now?
sir, shall one of us just show you the option that we use? If you can stop presenting, we will just present our screen and show you.
Okay.
Sir, over here you are having the presentation option. So there are 3 tabs: Brave, the window, and entire screen. So if you take entire screen and you give in the slideshow mode, it will be visible, sir.
Oh, okay. Yeah, I was doing window mode. All right, let me try that.
So I'll stop
See if it
sharing.
works. Okay. So let me try again.
There is no sound to that.
Can you see the slides now?
No, so you have not started
But
presenting.
my sound is clear?
Yes, sir. Yes, sir. It's audible.
Okay, now I see it. Okay?
Yeah, now it's
Yes, sir.
okay. Sir.
Yes, sir. Now it's okay.
Okay. All right. So I'll stop presenting and then
Okay, thanks. Sir.
I'll come back. Okay, thank you.
Good evening. Nitin sir, are we audible?
Yes, ma'am. So,
Yeah, thank you.
So we'll turn it back on. Professor Datta, we'll be turning it back on. We are trying to keep everyone silent as much as is possible. Okay. Meanwhile, Emily, please, whoever, please turn on the microphone of Professor Datta.
Sir, could you just try turning it on right now?
Okay.
Okay, can you hear me now?
yes.
Yes.
Yes, sir.
Okay.
Yes, sir.
Thank you. Thank you. Thank you.
Dr. Uwa, Lehmann, thank you for joining. Okay, we'll
Yes.
be muting you for a while, and then when the meeting gets going, we'll be putting you back on. Okay,
Yeah, thanks.
we can hear you now, and we can see you also, so you're safe. Okay, thank you.
Perfect. Thank you too.
Sudha ma'am?
Yeah, let's start. It's 9 o'clock, isn't it? Let's start.
Good morning, good afternoon, and good evening to all the participants joining us from across the globe. It is with great pride and pleasure that we welcome you to PESCCICON 2026, the International Conference on Power, Energy, Signals, Controls and Computation, hosted by Christ College of Engineering, Irinjalakuda, in collaboration with Christ College Autonomous, Irinjalakuda.
PESCCICON has always been a platform of inspiration, bringing together brilliant minds in technology and research. This year's theme, Energy for All, celebrates inclusive innovation and global collaboration across disciplines.
As we begin with this exciting journey, let's take a moment to seek the blessings of Almighty. We now invite Angel Maria from S7EEE for the prayer.
Thank you. Now, to formally welcome everyone to this global platform, we are honored to invite Dr. Sudha Balagopalan, Professor in EEE and Director of Outreach and Professional Development, Christ College of Engineering. Over to you, Sudha ma'am.
Thank you. Greetings from Christ College of Engineering to the distinguished personalities from different parts of the world. This is a momentous moment today, July 1, when we launch PESCCICON 2026, scheduled for July 1, 2, 3 in 2026. Why July 1? Because it is the birthday of our venerated conference chair, Professor Dr. Biswa Datta. Please join me in wishing Professor Datta a very happy birthday and a warm welcome to take up the reins of PESCCICON 2026. Welcome you, sir. Professor Datta has been instrumental in designing, nurturing, and enriching several such conferences with contents like keynotes, plenary sessions, workshops, contributed papers, tutorials, etc. But we add two more segments. In the student and the world segment, we add humanitarian technologies. And who else can we have other than Professor Dr. Pritpal Singh from the IEEE Humanitarian Technologies Board to launch this segment. Hearty welcome, sir. We prepare students for the industry, but it is technologies that pollute air, water, soil, and now another lifeline, that is the electric power. But technologies also offer solutions. We have with us Dr. Lehmann from Camille Bauer, GMC METROWATT, offering us some enlightenment on power quality. With pride and privilege, we welcome you, sir.
Thank you. Thank you very much.
To assist research challenges in the contributed papers segment, we have the professor duo, Professor Dr. Janet Ellen and Professor Dr. Farrokh Mistree, amalgamating the cyber, physical, social systems. They should have been with us here today, but are on a cruise celebrating their 50th wedding anniversary. Happy anniversary and happy welcome to you, dear professors. The conference has come to the launch stage because of the organizing strength, the support structure, and the encouragement of our CMI management. With fondness and respect, we welcome you, dear Reverend Fathers. Our executive has been a pillar of strength behind us, and we thank you and welcome you, dear professors. Christ College of Engineering has formed a well-oiled, synchronized machinery for the event, which is our blessing. Welcome, dear staff and students of Christ College of Engineering, Irinjalakuda. Our mighty neighboring institution, Christ College Autonomous, has given us confidence and viewership. With deep thanks, we welcome our fraternity from Christ College Autonomous. There are people from several walks of life embellishing this event with your presence. With profound gratitude, we welcome all of you. Our team of unsung heroes and heroines have worked day and night through their vacation to put up this show, dedicated to each one of you. Together, we take a bow and thank you.
Thank you, ma'am, for that warm welcome. Now comes a significant milestone, the official launch of PESCCICON 2026. We are deeply honored to welcome Professor Biswa Datta, Distinguished Research Professor at Northern Illinois University, USA, who will launch the PESCCICON website and deliver the inaugural address.
Before the launch, let us know more about Professor Datta's illustrious journey. We now invite Sanya from S5EEE to present his profile.
Dr. Biswa Datta, Distinguished Research Professor at Northern Illinois University, is internationally acclaimed for his groundbreaking work in numerical linear algebra and its applications in control theory and engineering. He has received prestigious honors, including the Fulbright Distinguished Chair Award in 2015, IEEE Fellowship in 2000, and Presidential Research Professorship in 2001. He has 100 research works with 1,827 citations. A sought-after speaker, he has delivered plenary talks worldwide and served as an IEEE distinguished lecturer. Dr. Datta has also led influential workshops and contributed significantly to research in optimization, matrix theory, and applied mathematics. Now, I gladly invite Dr. Biswa Datta to take over the session.
So you can press your screen if you want. So, sir, I think you are muted.
You have to unmute yourself, sir. You have to unmute yourself. Can you see that button? Also, Sunni, please help him.
Sir, there is a microphone symbol on your screen. Please turn it on. It will be in red right now. If you click it on, it will be turned on. No. Does that fix help you, sir? No.
Earlier it was okay. What happened now?
So if you can see the options below, then the first option, it will be in red right now. If you turn it on,
Is it fine?
So just remove your speaker, like headphones, and try with the system microphone.
Emlyn, all's fine on your side?
Yes, ma'am. Actually, I had made him a co-host, and now I have made it possible for everyone to unmute themselves. I cannot unmute anyone.
Okay, I suppose he might be better off without that speaker, isn't it? Yeah.
Datta sir, could you just exit from the meeting and join once again?
Can you hear us, sir? If you can exit from the meeting, just go out from the meeting and then come again, rejoin. Perhaps then you can join with everything intact.
Ma'am, he has unmuted, I think, sir.
Yes. Now he has unmuted.
Now it's fine.
Can you hear me now?
Yes, sir.
Yes.
Perfect.
Perfect.
Okay. Okay. Thank you. Thank you so much. Thank you, Beta. Okay. Good evening to you all, and good morning to some of you from USA. I'm sort of overwhelmed. I don't know what to say. I'd like to express my heartfelt thanks and gratitude to Dr. Sudha Balagapan for arranging this event on the day of my birthday. It makes me naturally very, very happy. I'm really thankful not only to her, to all the organizers who took part in this event today. Well, as I understand, this is a sort of pre-event to the real conference that is going to be held or planning to be held next year from July 1 to July 3rd. And that conference, as I understand also, is a sort of continuation of this series of conferences called PESCCICON, that were held at her former college at Vidya Academy of Science and Technology. Now, she was a principal that time, and her vision and dream was to bring excellent amount of research to that institute, where research is sort of not very well appreciated or well done. Main focus of such colleges are, as we all know, teaching. But she wanted to change the atmosphere, environment, bring some research to the university. To that institute, and hard work, leadership, and endless effort actually made that happen. Not only made that happen, all these conferences were highly successful, as is evident from the fact that many distinguished scientists, mathematicians, computational scientists, and engineers from different parts of the world, they were present and gave talk at this conference. All because of her sincere effort and hard work that were paid off. And so, what is my role here? She gives me some credit, but I really don't deserve any credit. All the credit goes to her. What was my role here? Well, at the beginning of the series of the conferences, she asked my help. When I looked into the theme of the conference, it immediately drew my attention. That is the theme of the conference was interdisciplinary, blending mathematics, computational science, and some areas of engineering like electrical and mechanical. And that is something I lies at my this is something that I always try to do myself. My whole career has been devoted to promote the interdisciplinary research between engineering, mathematics, and science. I have done research in this interdisciplinary area, organized several conferences, sponsored by American Mathematical Society, Society for Industrial and Applied Mathematics, IEEE, a society called MTNS, Mathematical Theory of Network Systems, and several others. I have tried to bring together mathematicians and engineers in one forum to exchange the ideas. So, did I succeed? Well, I was mostly successful, not as much as I wanted, because always I wanted some industry researchers come and take part in these conferences, but many of them decided not to do that for some reason. Anyway, but that has been my goal. Whole life I've been trying to do that. And when I got this call from Dr. Balagopalan to help her, I was more than delighted to do so. This is something I cherish at my heart. So having said that, I don't know what else to say, but I really wish her best of luck in going forward to have this other stage of conferences that she's planning to do in her present college. And I'm almost sure that she'll be very successful. Thank you so much, and Mistree.
Thank you, Professor Datta. Now comes the most awaited moment, the official launch of PESCCICON 2026. I invite Professor Datta to officially launch PESCCICON 2026 website by clicking the launch button. Yeah, and this marks the beginning of a remarkable journey of PESCCICON 2026. Thank you, sir.
And with that, PESCCICON 2026 is officially launched. Now, we request Professor Datta to proceed with the inaugural address.
Moving on to the next segment, the humanitarian segment. We now move on to the humanitarian segment of the conference, led by a pioneer in socially driven engineering, Dr. Pritpal Singh, professor at Villanova University and IEEE Humanitarian Technologies board member. Before we hear from Pritpal Singh, we invite Sania to give a quick glimpse of his profile.
Dr. Pritpal Singh is a renowned humanitarian engineer and professor of electrical and computer engineering with a 4-decade career dedicated to serving underserved communities. Recipient of the 2022 Duncan Fraser Global Award, he is known for his impactful work in renewable energy, sustainable engineering, and community empowerment. With over 100 publications and 7 US patents, he has led major projects such as telehealth in Nicaragua and solar water disinfection in Ecuador, supported by organizations like UNICEF. A 2023 Fulbright Scholar, he continues his mission in Ecuador, collaborating with ESPOL on sustainable technologies and renewable energy for the Galapagos Islands. I kindly request Dr. Pritpal Singh to take over.
Thank you so much, Sania, for that kind introduction. And thank you to the organizing committee, especially to Dr. Balagopalan. We met in the IEEE Power and Energy Society Power Africa Conference, and I've been very impressed with the work she's been doing in the humanitarian space. And also I want to wish Professor Datta a very happy birthday and congratulations on the launch of this initiative. So I have some slides that I'll share. So let me share my screen. So it's my honor and pleasure to address you today as a representative of the IEEE Humanitarian Technology Board. So I'm going to give a quick overview of the board. And so I'll skip my introduction since you already gave a very kind introduction for me. So the IEEE Humanitarian Technology Board, just to give a little bit of context, was established a few years ago, but built on a history that started back in 2009. So in 2009, I made my first trip down to Nicaragua, and we were looking at doing some project work there. So I went in May of 2009, and then when I returned in June of 2009, IEEE held their first humanitarian technology based gathering. And the concept behind that was we have the largest professional organization in the world in IEEE. And we have all these technologists with great skills and doing wonderful volunteer work. And how can we gather and use their skills and knowledge and that of students and so on to address some of the humanitarian needs in the world. So that was the origin of the IEEE Humanitarian Initiative. And in the last couple of years now, the humanitarian initiatives have come under one umbrella called the IEEE Humanitarian Technology Board. And the mission, as you can see from the slide, and the website is indicated below, is technology for social impact. how can we use technology to really address and improve the condition for people who are underserved? And so the IEEE Technology for Social Impact is focused on IEEE humanitarian technologies to support impactful and ethically informed volunteer-led initiatives, programs, and projects. So when we look at the HTB programs, there's a number of different programs in a consortium that were all brought under the same umbrella 2 years ago. So we have IEEE Site, IEEE Reach, IEEE Tech for Good, MOVE, EPICS, Smart Village, and Empower a Billion Lives. And the goal of this program, or the set of programs, is to address the UN Sustainable Development Goals. So with that, let me just highlight a couple of programs under this umbrella. And the first one I want to highlight is Tech for Good. So Tech for Good is basically an opportunity to write grant proposals and get funding, grant funding to do humanitarian projects within the context of a local community. So it should be led by a local community member or engage with the local community. It can be NGOs, it can be university, student branches, and so on. And you can get up to $10,000 to implement a project that is helping to support the improvement of conditions of people in underserved communities. I've received grants from Tech for Good. Just as an example, we installed a solar electric system in a university in Burundi. And then we also did a similar project installing a solar electric system for a community tailoring business in a rural part of Burundi. So these are the types of projects that you can apply for funding for and get support to do humanitarian project work. Another group that you should be aware of is IEEE Site. So a Site group is a group of people who are interested in working in a humanitarian engineering project. And SITE stands for Special Interest Group in Humanitarian Technology. And you need at least 6 people to set up a SITE group. And then this allows you to be able to get some funding to do some little bit of work. It doesn't really provide a lot of funding, but it provides the opportunity for you to mix with people with similar interests, similar mission, and to develop proposals then that you can submit for the Tech for Good program. Another project is the EPICS project. This is Engineering Projects in Community Service. And they basically have students working with communities, closely working with them to create community-driven accessibility solutions. And they have 2 calls for proposals twice a year. Once is in, I believe, March, and then also, as you can see from the slide here, in October. So if you're interested in working with the community and having a community-driven solution, EPICS is a good program. And then finally, the Smart Village program is one that I've been involved in. Dr. Balagopalan has also participated in the Smart Village program. And Smart Village uses a different model. They don't provide grant funding. They provide seed funding for an entrepreneurial venture. So the idea is you set up a for-profit company and you develop a business to improve the lives of people in communities. And so a simple thing might be that you set up a solar electric system, and then you have the solar electric lights that you distribute to the community, and then you charge for the recharging of those lights. And so you make some profit from that, and at the same time you're bringing a clean technology to the communities, providing a better quality of light than they would get from kerosene lamps, as an example. But the idea is to come up with a venture. So it has 3 pillars: entrepreneurship, the technology, and then the community engagement and education around that. So these you can start with the initial pilot venture and get up to $25,000, and then you can apply for more funding to scale that, and you can apply for up to $200,000. But there is an expectation that you'll also raise matching funds from other investors. So these are some of the programs that are offered under the HTB umbrella organization. And so I hope that you will consider looking for support through these, or even contributing your volunteer time and knowledge to these humanitarian technology opportunities. So thank you for your attention. I'm really excited to see how the conference develops for next year.
Thank you, Dr. Singh. We now move into our industry-oriented segment, focusing on power quality, a crucial topic in modern energy systems. We are delighted to welcome Dr. Uwe Lehmann, Business Development Manager, Camille, Bauer, GMC METROWATT, Switzerland. Before we invite Dr. Uwe Lehmann, we request Sanya to give a short description of his profile.
Dr. Uwe Lehmann is a seasoned expert in Europe business development, specializing in measurement technology and solutions for monitoring and managing electrical energy. He focuses on ensuring stable energy supply, reliable industrial and data center operations, and efficient investment use. By delivering tailored tools and services, he enhances energy resilience and system availability in complex production and computing environments. Now, I happily invite Dr. Uwe Lehmann to take over the session.
Thanks a lot. I have to start my presentation. So. Yeah, thanks a lot for the introduction and kind presentation of myself. And I also like to gratulate for the birthday of Professor Datta. Yeah, congratulations. Now, I want to speak about the challenges for grid operators we're facing now and in the future as well, more in detail. And yeah, I like to discuss that and what are the possibilities to ensure or fight against the problems or challenges coming up here. Wait a second. I like to begin with an analogon. Would you like to drive a Ferrari like you see there on the right picture on the top on a gravel road like you could see below? I won't do so. And somehow it's the same with the power grid. The availability is an issue, sure. This is due to the availability of the tools, respective production equipments, which is directly linked to the grid stability. Yes, the efficiency and performance of the end user tools is linked to the power quality in the grid as well. The distribution grid infrastructure must provide stable and good conditions for optimal utilization of the operating resources on the grid operator side and on the customer side. Now I like to speak about the grid phenomena we encounter every day. Short introduction on that. And the frequency fluctuations are of crucial importance in terms of instability of the supply grid with regard to feed-in, consumption, and consumption power, and could regard to shutdowns. Also, we are facing voltage level changes, could regard to shutdowns, data loss, and malfunctions of end-user equipments. Flicker regards to light flickering and influences the work performance of human resources. Dips and rapid voltage changes regards also to shutdowns, data loss, or malfunctions. Voltage interruptions caused by short circuits, blown fuses, etc., regards to loss of production, data loss, etc. Unbalances caused by unsymmetrical load of the phases regards to heavy neutral line currents, overload of equipment, and increase in harmonics. Harmonics are sinusoidal components, which are integer multiplies of the main frequency, superimposed on the voltage or current. Interharmonics are sinusoidal oscillations, which frequency is not an integer multiplier of the fundamental frequency, and regards also to problems in the grid. At least we have the transient overvoltages, often confused with rapid voltage changes. These are high frequency events with very high voltages as well, and then we're speaking about several thousand volts in this spike. These are events mostly in the microsecond range, so very fast events. Could also regard to problems in the grid. Now, the new challenges the grid operators are facing most regards to the load have been changed from predominantly resistive to power electronic based load profiles. High frequency current demands from frequency converters and large switch mode power supplies place substantial stress on the grid installation and influences other grid participants as well. In order to make the power grid resilient, complex adjustments will have to be made. This concerns monetary investments, time, and construction measures, and other things as well. So the solution for existing grids can only be closer monitoring and reducing the emission of harmonics from industrial complexes, for example. On the top right side, you see a graph showing the impedance profile in regard of the harmonic frequency, respective order. Therefore, you have to divide the frequency by 50 Hertz in this case, for example. It could be seen on the top side, on the top right side there, that the grid impedance is strongly influenced by the load type of at the end user topology. For example, a big inverter has a huge impact at the specific frequency. And the greater the impedance or the impact on the power quality. These graphs I cited from an article, Professor Höckel, University of Applied Science in Bern, the main capital of Switzerland, and his colleague, Mr. Meyer, teaching on the Technical University in Dresden, Germany. have been published in 2019. In the graph below, on the right side, it could seem realistic measurements and the grid impedance is more complex close to the point of common coupling. These are the dotted lines you could see there. So mostly they're on the top. Closer to the transformer, there the impedance is more flat. These impedances have the biggest influence on the voltage quality and affects other grid users highly. Why power monitoring is needed? Power quality instruments also providing power monitoring functions. So I will discuss these here as well. Power monitoring is used for cost reduction on end user side. This function is also used for improvement of the equipment uptime on grid operator and end user side as well. Fault current detection enables targeted maintenance, and you do not have to make then prevent maintenance anymore. This is usually in production equipments the case to prevent accidents on human operators, for example. Extension of plant availability of facilities, and there you need such load monitoring as well for to make the planning and extend the plant. Monitoring the load on power grids for grid planning is needed, and if necessary, direct dimming of the loads to protect the grid is infrastructure will be damaged. This is actually the case currently in Germany. The German power grid operators are forced by the government to monitor the grids more carefully, and in case the grid is endangered, to dim the loads at the end customer side. So at your home as well, for big loads like thermal pump or car loading stations could be dimmed down by the grid operator in case of danger. Next year, the European Union will go beyond to exciting CBAM measures and declare further energy-intensive products that must be reported in terms of their CO2 footprint. This is also relevant for foreign countries. If you have their or a CO2 intensive product, which is on the list in the future as well, then you have to monitor and report the CO2 footprints of the products to import your product into the European Union without any fee. At the end, the individual grid parameters have to be monitored for power generation and supply as well to ensure a safe power supply. Why power quality monitoring is so important? Overheating of electrical motors and transformers mostly due to heavy harmonics, for example, need to be done. You see here on the right side a transformer which get too hot and start burning. This is a real photo from Germany. Neutral line could be overloaded by imbalances, for example. This is also dangerous and could regard to fire as well. Feeder and cables could be damaged and altering faster by overloading. Higher reactive power leads to increased energy costs, for example. This is important for industrial applications. They have to reduce the reactive power, otherwise this will be charged. So you have to monitor that as well. Malfunction of electronics and control system, which also could lead to noise development, for example. Unexpected server shutdowns could coming up, etc. And at the end, flickering of lamps and monitors, which leads to insufficient human work output. You see him there sleeping on the left side. Here I would like to briefly show you permanently installed measurement devices for power monitoring and power quality monitoring, corresponding to the power monitoring devices which comply with the IEEE 61557 standard, are suitable for power and energy measurement and monitoring of all electrical grid variables. Power quality measuring devices are divided in two classes, Class A and Class S devices. Class A devices are comparable with each other, regardless the manufacturer. As soon as you have a Class A device, the reports coming out there are very reliable and everybody is believing that, independent on the manufacturer. These classifications could be certified by independent institutes. You see there on the right side, golden stamp, showing our devices are certified by the METAS. This is a Swiss independent institute for such reasons as well. The statistical PQ reports see on the top right side, there are some slides coming out of that, be created in accordance with the common and customized standards. For example, EN 5160 is a European standard, IEEE 519 is a US standard, GPT is a Chinese standard, and followed by the industry standards. This could be chosen on the device. No additional software is required for these devices to generate PQ reports. This is provided via the web server on the device directly. In the table, you can see an excerpt from the function of the PMD devices on the green side or green columns. And the additional functions provided by a power quality analyzing system are shown on the red side. Both device types offer monitoring of harmonic distortions, which are becoming increasingly important in our power grids, as we have already seen. The newest development is an elegant multiple measurement tool for load profiles used by one measuring device. This is done by the PME modules. Up to 33 feeders can be monitored with this PME technology. Easy installation due to wireless communication is established, and high current monitoring available up to 1200 amps per wire, per Rogowski coil, you could measure that. Applicable in low and medium voltage levels is here possible with this device type. There's also a cable-based version in form of Current Link available. Both versions, Current Link and PME, are available in the form of the smart grid box shown on the bottom right side, which also provides an integrated GSM router if required, and no Ethernet available on the transformer station, for example. A cloud-based data management platform is also available, which is ISO 27001 certified, ensuring secure data transmission across the entire communication path and server infrastructure. This is established by this ISO certification 27001. I would like to introduce you to mobile measurement devices as well. This is a single-channel mobile power quality measurement device. It offers the possibility to evaluate harmonic emissions in the electrical grid. In this case, a report is generated that clearly illustrates the situation and quantifies the harmonic emission of the site you are checking. So this is also quite important. If you have their site emitting too much harmonics in the grid, this regards to problems surely on the grid side, as we have discussed before. So making a measurement and clarify the situation, it's very useful to establish a stable grid. Finally, I would like to introduce you to a mobile multi-channel measurement device. This enables current measurements of up to 20 kiloamps per wire, per Rogowski coil, and up to 9 feeders could be monitored with that on 3 phases or 3 phases and neutral line. This is variable. You could distinguish what you like to do there. With the PQ5000 mobile CLM, M stands for multi-PQ. You have 9 PQ analyzers in one device, like you see there on the top right side. It's very handy. It's a small box, high IP, environment protected. You could leave it somewhere in a transformer station or distribution station for 1 week and make the measurements there and get an overview what's happening on the grid. At the end, I want to present you a software. It's also provided by Camille Bauer to collect and evaluate the large amount of data generated by the devices in your grid infrastructure. Smart Collect is the customer-based SCADA system that also provides PQ analysis functions. If you want to get more information about that, you could connect me via LinkedIn, no problem. I will respond immediately. Or, you also could see my data here, my contact data on this slide. Thanks a lot for your attention, and I wish you a lot of success for the conference. Thanks a lot.
Thank you, Dr. Lehmann, for your industry perspectives.
Today, 2 of our distinguished contributors, Dr. Farrokh Mistree and Dr. Janet Ellen from the University of Oklahoma, USA, are celebrating their 50th wedding anniversary and are currently on a cruise. Despite their absence, they have graciously shared a podcast discussing ongoing research challenges in their field. Before that, we invite Sanya to give a quick glimpse of their profile.
Dr. Farrokh Mistree and Dr. Janet K. Allen, endowed professors at the University of Oklahoma, are internationally recognized for their contributions to engineering design and systems realization. Formerly at Georgia Tech, they have co-authored influential works on design science and complex engineered systems. As coordinators of the System Realization Laboratory, they lead research in knowledge-based design and are committed to mentoring the next generation of engineering leaders.
Thank you, Sanya. We are pleased to now play that podcast for you.
Mistree and I are delighted to be here at the invitation of Sudha Balagopalan to talk to you today about smart services for sustainable communities, some research issues.
Today we are going to touch upon 4 aspects of what is needed to bring about smart services as evolving cyber-physical social systems at institutions of higher education in India. First, we're going to identify India's development paradox. Then, to respond to these paradoxes, we're going to propose smart services as evolving cyber-physical social systems be undertaken by universities in India. To make that happen, we suggest that there needs to be a research and education ecosystem, and so we'll touch upon that. And then finally, we will talk about the next steps to take post our presentation. India's development paradoxes, there are 2. India's GDP ranks 5th in the world, but India's GDP per capita ranks 140th in the world. This is a big disparity, and that's the first paradox. How can we increase India's GDP per capita so that it is not so low in the world rankings? The second paradox exists out here. Manufacturing accounts for 13% of the GDP, and the service sector accounts for 53% of the GDP. This is the second paradox. How can we help the service sector to increase its contribution to the GDP so that the per capita ranking goes up in the world? In passing, I will mention that micro, small, and medium enterprises account for 27% of the GDP in India. To respond to these 2 development paradoxes, we propose that the universities in India adopt the smart systems as evolving cyber-physical social systems paradigm. Smart systems are human-centered, AI-enabled, and evolving. They are designed to increase disposable income of rural micro-entrepreneurs over time, and we need a curriculum that is aligned with the National Education Program 2020 and Kalam's purer vision to make this happen. There needs to be an ecosystem, a research and education ecosystem, and we will touch upon how one can organize the research thrusts, and 2, how one can foster continuous learning through experiential learning. Finally, we will ask you to contemplate what are the next steps. We suggest 2, collaborative research with the goal to publish between faculty in India and us, and 2, to co-develop and implement an experiential service learning program in India.
To accomplish this, we believe we need a smart services ecosystem. Now, smart services are cyber-physical social systems. They are human-centered, AI-enabled, evolving, and of course they are smart. They are designed to sense, learn, and adapt in rural settings. Education programs need to be aligned with NEP 2020 and President Kalam's pure vision. Students need to learn how to work with entrepreneurs and faculty mentors to co-create outcomes tailored to local contexts.
To bring that about, one needs policy. That policy needs to be aligned with the National Education Program 2020 and PURA. The National Education Program 2020 has 3 elements that are foundational to the proposition that we put before you today. One is nation building. All institutions of higher education in India are encouraged to contribute to nation building. All institutions of higher education in India educate people who go and work for companies in India. The second portion is educating people to go and create jobs, be entrepreneurs, and provide jobs for others in the service sector. That, we believe, is lacking. The second is that in the National Education Program 2020, there is an emphasis on transdisciplinary research, on fostering this. There's funding available for this to make it happen. And third is that faculty in India are encouraged to collaborate within India and then to seek international collaborations. These three are foundational to what we have proposed today. President APJ Abdul Kalam proposed PURA. What is PURA? It stands for Providing Urban Amenities in Rural Areas. What is an amenity? It is a service. The idea is people from the villages do not migrate to the cities and cause problems. Now, Abdul Kalam proposed that if there were education services, healthcare services, sanitation services, transport services, and livelihoods that were comparable to what was provided in the urban areas, people from the rural areas would not seek to emigrate or migrate to the urban areas.
So let me tell you about what we can contribute to the ecosystem. We're interested in designing smart services for sustainable societies. We seek to identify principles, mathematics, and frameworks that enable stakeholders to design human-centered, AI-enabled smart services. We model development and policy as evolving cyber-physical social systems in order to integrate people, technologies, and institutions into adaptive ecosystems that support innovation, policy resilience, and sustainable communities. The core of this is the policy and strategy designing, and we have 5 coordinated research trusts to accomplish this. The first, up in the upper left, Shiavas Mandagai, is interested in sustainable development as an evolving cyber-physical social system. Bauer is a PhD candidate. He's interested in adaptive policy and strategy design. Sarah Hajashimi, predictive analytics for future planning. Shiva Ashtari, generative AI for entrepreneurship. Saramya Sarkar, context-aware control for service systems.
So in our laboratory, we've organized our research around 5 interlocking trusts, as Janet has pointed out, and we invite faculty in India to work with us in any of these trusts or multiple trusts. The primary thrust, Sustainable Development as Evolving Cyber-Physical Social Systems, is aimed at realizing context-aware, human-centered sustainable development by treating it as an evolving socio-technical system. The secondary thrust, Designing Adaptive Policies and Strategies as Evolving Cyber-Physical Social Systems, our aim here is to create the governance and decision framework by providing adaptive intelligence to guide evolution towards sustainability. Our tertiary thrust 1 is Predictive Analytics for Anticipatory Action. This is to support policy design under uncertainty by enabling proactive, evidence-informed decisions that shape resilient pathways for sustainable development. Tertiary thrust 2 is Generative AI for Sustainable Entrepreneurial Strategy, and it's aimed at supporting inclusive policy implementation by enabling communities to co-create sustainable economic strategies that adapt to changing markets, resources, and needs. Tertiary thrust 3 deals with context-aware control systems for service delivery. This is aimed at supporting the execution of adaptive strategies by enabling real-time system coordination and ensuring that smart services evolve in step with policy goals and societal context.
Now, turning to education, we believe a paradigm shift is needed. We want to educate people for continuous learning. Faculty need to shift from rote and pedantic learning aimed at training students to be problem solvers in order for them to become lifelong learners who learn by reflecting on doing. Faculty and mentors need to prepare students for lifelong learning in evolving context. We welcome collaboration to realize a designing for services curriculum that helps students to become lifelong learners. We have published extensively in this area, and we would welcome collaboration here. We are aware of and respect existing programs in India that support rural transformation and faculty engagement. Some of these programs are Adopt a Village, the Atal Innovation Mission, and the DST Travel Grants. We invite smart partnerships that align with smart services research with India's national priorities and which lead to scholarly publications. We invite faculty in India to join us in co-designing a Designing for Service curriculum that reflects NEP 2020 goals and the UN Sustainable Development Goals as priorities. Faculty in India with DST funds may visit the Systems Realization Laboratory to further collaborative research.
So what are the next steps? We have aligned our vision with the NEP 2020, the purer notion of Abdul Kalam, and the IEEE Humanitarian Technologies Board's mission to harness technology for sustainable development. We look forward to collaborative research, curriculum development, and smart services that honor India's diversity while advancing global sustainability. We thank the management, staff, and students at Christ College of Engineering and Christ College Autonomous Thrissur in Kerala for enabling this gathering. In closing, we ask you to reflect deeply on what we have put before you and then act as you judge best. We hope this action leads to collaboration with us and we both enjoy this journey. Please feel free to contact us at our email addresses, and we look forward to being in touch with you, and may you have a very happy life.
Thank you, Dr. Farrokh and Dr. Janet. We now move into our felicitation segment. We first invite Reverend Father John Palikra, CMI, Executive Director of Christ College of Engineering, for the felicitation. Father John is the founder of Christ College of Engineering, Irinjalakuda, and its Executive Director since 2015. He is a recognized academic visionary and a recipient of the Inspiring Education Hero Award by EJN India in 2025. With an MBA in Hospital Administration from USA, he also served in the past as the Joint Director at Amala Institute of Medical Sciences, bringing a unique blend of healthcare and academic leadership. He is truly our educational luminary, a legacy of vision and life of impact. Over to you, Father John.
So thank you, Singh, for your nice words. Respected dignitaries, esteemed guests from across the globe, distinguished academicians, researchers, industry leaders, dear students and friends. It is with immense joy and a deep sense of pride I rise to offer my heartfelt felicitations on the occasion of PESCCICON 2026, an international gathering that truly stands at the intersection of innovation, collaboration, and education. Let me take a moment to express special gratitude to Professor Balagopalan, a visionary leader and a tireless connector of people and ideas. Thank you, Professor Sudha, for being the bridge that brings together diverse minds from different corners of the world for a common cause, knowledge, growth, and impact. To every participant, presenter, and a collaborator, thank you for being part of the intellectual journey. May PESCCICON 2026 be a milestone not only in academic achievement, but also in fostering enduring partnerships that empower generations to come. Let us continue to dream together, build together, and rise together for a better tomorrow, powered by knowledge and driven by purpose. I wish a wonderful birthday to Professor Nath and have a happy wedding anniversary to Professor Farrokh and Professor Allen. Thank you. Bye-bye.
Next, we welcome Reverend Father Jijo Francis, PESCCICON Coordinator from Christ College Autonomous, for the felicitation.
Hi, respected dignitaries, distinguished guests, fellow academicians, and dear participants. It is my great honor and privilege to offer my heartfelt felicitation on the official launch of the Power, Energy Signals, Control and Computation International Conference, PESCCICON 2026. I represent Christ College Autonomous Irinjalakuda, Kerala's largest arts and science college with a vibrant academic community of over 5,300 students. Established in 1956 and affiliated with the University of Calicut, our college is a government-aided institution administered by the Carmelites of Mary Immaculate CMI under the Syro Malabar Catholic Church. In 2022, we were proud to become the first college in Thrissur district to earn an A++ grade accreditation from the National Assessment and Accreditation Council, NAC, a recognition of our continuous pursuit of academic excellence and innovation. We are uniquely positioned in a shared education ecosystem. Both the campuses of the Christ College Autonomous and Christ College of Engineering are situated at the same campus, symbolizing a seamless blend of arts, science, and technology. It is within this dynamic and interdisciplinary environment that we celebrate the spirit of PESCCICON 2026. This international conference, with its focus on power, energy, signals, control, and computation, reflects the very ethos of collaboration and cross-disciplinary inquiry. In a world increasingly shaped by technological convergence and smart systems, PESCCICON is poised to become a vital platform for global exchange and pioneering research. I extend my sincere congratulations to all our visionary organizers, collaborators, and technical committee members who made this initiative possible. Your commitment to academic leadership and innovation is commendable. On behalf of Christ College Irinjalakuda, I wish PESCCICON 2026 great success in creating transformative knowledge, empowering future researchers, and fostering meaningful global connections. Thank you, and may this be the beginning of many impactful contributions to science and society. Thank you all.
Thank you, Father John and Father Jijo, for the felicitation address.
And now, as it's time to conclude the formal segment, we now invite Dr. Sajeev John, Principal of Christ College of Engineering, to deliver a vote of thanks.
Respected dignitaries present and all the participants. Good evening to one and all, and good morning to some of the dignitaries from abroad. I'm really happy, and it's really proud and consider it an honor to extend heartfelt vote of thanks on behalf of the Christ College of Engineering and the organizing committee of PESCCICON 26. First and foremost, our sincere gratitude to all the distinguished speakers for gracing this launch with their inspiring presence and insight. Initially, I would like to thank Professor Biswa Datta for all the motivation for this program. Thank you, sir. Next, I would like to thank Dr. Pritpal Singh for taking a nice session on humanitarian segment. We had a wonderful session on power quality by Dr. Lehmann. Thank you, sir. And also, I would like to thank the podcast by Dr. Janet Allen and Dr. Farrokh Mistree. I would like to take this opportunity to thank the entire management team for giving the great support for this program. And also, I would like to thank the Professor Dr. Jolie Andrews, the Principal Christ Autonomous, and Reverend Father Dr. Jijo Francis for gracing this occasion. I would like to thank the woman behind the program, that is Dr. Sudha Balagopal, for such a wonderful initiative, along with the team members, Mr. Nitin and Ms. Emily. Our And big thanks to all the participants and attendees who joined across the globe for this program. Thank you. Thank you all.
Thank you, Sajeev sir. Now, we request all participants to please turn on your cameras now for a virtual group photo.
Dear participants, kindly turn on your cameras to capture this momentous occasion.
Okay, so now the floor is now open for a 10 to 15 minute feedback and discussion session. Please feel free to share your thoughts or reflections.
Professor Toby has raised his hand. Would you like to say something, Professor Toby? It was nice of you to join us. Professor Toby, had you raised your hand purposefully? Toby, are you still there? Fabian sir, would you like to say something?
The participants can turn on their mic if they have any questions.
So if nobody has a question, I think we should wind up, isn't it? So giving you a chance to say happy birthday to Professor Datta. Whoever wanted to switch on their audio, they could have said a happy birthday.
Happy birthday, Datta sir. Happy birthday, Datta sir. Hope I am audible, Sudha ma'am.
Yeah, you are, Mary. We heard your happy birthday wishes. I think something is wrong with the audio of some people. Perhaps they are not. Emily, have you switched on everyone's audio?
Hello, good evening. And thank you, Sudha ma'am, for sharing the link with us as well. And all the best wishes for the conference. And many more happy returns of the day, Datta sir.
Thank you, Akshila, for joining. Thank you, Mary, for joining. Thank you for everyone whoever joined based on the invitation we sent out. It looks like Professor Toby wants to say something, but then perhaps he's not able to unmute himself.
Yeah, Mr. Toby have raised his hand again.
Would you like to chat, Professor Toby? Would you like to chat something? You can put it on the message.
You can even send the message in the chat if you are finding it some difficulty to turn on your mic.
There are plenty of messages on the chat saying that humanitarian technology was a very good segment. I suppose you might have noticed that all the three segments are interconnected, okay? In our homes, the neutrals get heated up and we don't know, and there is a possibility of a fire. So we had better, everyone needs to know a little about power quality as well. Oh, how is that, Camille? Professor Toby can't switch on screen.
Yeah. Mr. Toby have message. Yeah. Elizabeth, ma'am.
Yeah, thank you all. Thank you all the professors who gave very good talks. It was actually very good, and I hope the conference will go very well. And congratulations to all the people who were behind this. Thank you, and good night.
Thank you, ma'am. You are definitely one of our inspirations.
Thank you, Sudha.
Hello together. I have a question actually. Also, I want to say congratulations for the good session today. But are you sharing the presentations?
Are we sharing?
The presentations we have seen. Yeah, the presentations.
If you send it over, we'll definitely share it. We'll have it in our repository because we are slowly designing our conference website. We can definitely put it there. But then we don't want the relation to end, Dr. Uwa. We would like it to be taken forward because we are interested in laboratories wherein we can have some kind of power quality measurements being taken and such that we can have some consultancies. This is a very important field right now, and we would like to keep the contact going. Is it okay for you, Professor Dr. Uwa? Yeah.
Perfect. That's great.
Yeah, I'll be talking to you more on this, okay? Because we are trying to set up a power quality lab here. In that case, we will definitely want your help and all kinds of assistances.
Perfect. That sounds good. Thanks a lot.
Yeah, thank you for coming over. We understand that it's a very busy time for you and it's not a very comfortable time for you as well. But still, you are here. Thanks an immense lot.
Yeah, thanks.
Yeah. So thank you. You may also submit your feedback through the Google form shared in the chat. Certifications of participation will be issued upon request through the same form.
Thank you, Professor Datta. Thank you, Professor Pritpal Singh. We were actually very fortunate to have you today here. And I believe that many people enjoyed the proceeding today. And we hope for more because a year is still to go before we have the actual conference. But still at the same time, many people have logged in. We hope for more participation as the days go by.
Okay, so as we bring this inaugural session of PESCCICON 2026 to a close, we express our heartfelt thanks to all our speakers, guests, organizers, and participants.
Thank you for being a part of this journey, for witnessing innovation in action, and for your commitment for shaping the future through research and technology.
We look forward to seeing you all again at the in-person PESCCICON 2026. Until then, take care and keep innovating. Thank you for joining us, and goodbye until we meet again.
One more minute. Thank you, Professor Suni. Thank you, Professor Nidhu, for adding so much of grace to the full program. Okay, so you actually kept it all together, just as we wanted you to, and we are very grateful to you both.
Thank you, ma'am.
Thank you, ma'am.
And thank you to the dear children who also made some presentations.
Thank you, everyone. Once again, it's me, Suni, signing off.
And it's me, Midhu, signing off.
Thank you. Have a great day. Thank you.
Yeah, we'll meet again.
Thank you, ma'am.